So, section 13, pink booklet, equation practice. What we're doing here is we're looking at moments. What we're doing is looking at turning force. And the turning force, okay, or moment, capital M, is force times perpendicular distance, which we record as D here. So this is M for moment, turning force, and the units are Newton meters, because it's a product of force, newtons, and the distance, meters. So, loading man questions. So, calculate the moment of the force of a boy on a seesaw weighs 450 newtons and he is 0.5 meters from the pivot. So, calculate the moment. So, here we go. So, we've boxed, underlined, we're going to grab our data. Force is equal to 450 newtons. And we have distance is equal to 0.5. So we have, now we need our formula. Moment is equal to force times distance. Now we need to insert. So it's just 450 times 0.5, which is 225. Moment is Newton meters. So 225 here. Now, what's the moment of a force when I go? The moment of a force, that's what we want. Box that. The moment of a force when a girl turns a spanner with a force of 10 newtons and is 0.3 meters away from, which is 0.3 meters away from our hand. So we've got moment, don't know, data, we've underlined, and we're going to grab it. So force is equal to 10 newtons and distance is equal to 0.3 meters. So moment is equal to force times distance, which is equal to 10 times 0.3, which is equal to 3 Newton meters. There we go. Now, moving on. Looking on to the standard demand questions. So, write down the equation for the moment of the force. Force times distance. What is the moment of a force? So into box what we're finding. If it pushes at a crowbar handle with 46 newtons in his hand is 26 centimeters away from the pivot. So we've boxed, underlined. So we're finding the moment. Data. Well, the force is 46 newtons and the distance is 20, I've jumped ahead, 26 centimeters, which centimeters here, which gives it 0.26 meters. So we can now do formula. Insert 46 times distance, which is 0.26. So 46 times 0.26, and that is equal to 11.96, which I'm going to call 12. So, write down the equation of the moment of force. So, what is the force exerted on a door? So, force is what I need to find out. When the turning effect is 36 Newton meters, so moment is 36 Newton meters. And the handle is 0.6 meters away, so distance is equal to 0.6. So formula, I nearly wrote that formula down. Moment is equal to force times, force times distance. So now we need to insert the data. So it's 36 is equal to force times 0.6. So it's actually going to be 36 divided by 0.6, which will give me 60 newtons. So moving on. And we've got some standard high demand questions. So write down the moment of a force. Moment equal to force times distance. So we've got what force? So we're going to put F is exerted by the foot if there is a moment of 7 Newton meters at the brake pedal and the foot is 10 centimeters away from the pivot. So we've got a force that we're finding. So we've got that. We've underlined the data. Now we're going to grab that data, and we've got moment is equal to 7 Newton meters, and we've got distance is equal to 10 centimeters, which is actually equal to 0.1 meters. No, sorry, 10 centimeters. I think it's right. Yeah, 0.1. Why am I checking that? Anyway, senior moment. So now we've got our formula. Moment is equal to force times distance. So now we're going to insert our data. So we've got 7 is equal to force times 0.1. So we need to rearrange. So because this is times, I need to move this to the other side. So if I divide this side by 0.1 and that side by 0.1, it'll cancel on the right hand side and leave me with 7 divided by 0.1, which will equal 70. But you knew that anyway, didn't you? So force is 70. Now it says pascals here, so I'm just going to get rid of that because it's newtons. Now moving on. Write down the equation for the moment of the force. So moment is equal to force times distance. So the turning effect caused by so now we need to calculate the turning effect caused by the earth force in the diagram is 15 newtons. Oh, so we don't. The perpendicular distance between the line of action of the force and the pivot is 60 centimeters. What force is the handle pulled with? So there it is. I'm actually finding force. I don't know. On my data, moment is equal to 15 newtons. Perpendicular distance, D, is 60 centimeters, which is equal to 0.6 meters. So formula, moment is equal to force times distance. Insert 15 is equal to force times 0.6. So 15 divided by 0.6 will equal force, which is equal to, so we've got 15 divided by 0.6, 25 newtons. There we go. So now we come to our last one. Okay, so in the diagram below, the drummer's toe pushes with 1.5 Newton force on the foot pedal. You can see this one. Okay, so there's the 1.5 newtons. The perpendicular distance from the pivot to the force is 0.12. So this is our pivot here. That's where the pivot is, and the distance there is 0.12. The perpendicular distance from the pivot to the chain is, so from the pivot to the chain is 0.2. So the force is acting here about this pivot. Okay, so what we need to do is we can see here that we've got two forces. We've got the force about, well, two forces acting about this pivot here. You have the force from the toe acting this way, and that means because of the pivot, the force on the chain will act in the opposite direction. So if we take this and redraw this, there's our pivot, there's our foot pedal. Now here is our force, and that distance there is going to be 0.12 meters. So we now have a chain here which is 2 meters away from the pivot here, 0.2 meters here, and when we push down here, that pulls on this chain here, so the force is acting this way in the opposite direction. So this is what we've got then. Now this force here, if we take it about the pivot, you can see that it goes this way, which is our anti-clockwise moment. This force here, if we take it about the pivot, is acting in a clockwise direction, so we can call this a clockwise moment. So we know from our principal moments that the anti-clockwise moment is equal to the clockwise moment. So let's have a look at the anti-clockwise moment then. Well, the anti-clockwise moment is force times distance. The force is 1.5. That's 1.5 times 0.12, which is our distance. And that's equal to the clockwise moment, which is some force that we are calculating, because that's what we need to find. Calculate the force on the chain acting on the foot pedal. So that's our force times this distance here, which is 0.2. So what we can do now is do this a number of ways. Either work this out first and then divide it by 0.2, or just quite simply say that 1.5 times 0.12 divided by 0.2 is equal to our force. So what we've got then is 1.5 times 0.12, which is equal to 0.18 divided by 0.2, which will give us 0.9. So calculate the force on the chain. It is 0.9. That's a force, so it's newtons. Okay.